Today we're going to look at graphing linear inequalities. So first we'll look at the situation that we do in class. When looking at the past season, Michaela scored no more than 12 points a game. She scored 2 pointers and 3 pointers. So number one, can you define the variables and write an inequality to represent the situation? So there's two variables here. There's 2-point shots. So, oops, it's too thick. So we'll say 2-point shots. The number of, I should say. And there's also the number of 3-point shots. So we could write an inequality that represents that, and I'll do it up here. And let's say 2-point shots are x, 3-point shots are y. So you have 2x plus 3y. So the number of 2-point shots plus the number of 3-point shots. And she scored no more than 12 points per game, so less than or equal to 12. So 2 times the number of 2-point shots plus 3 times the number of 3-point shots should be less than or equal to 12. So in class, with our table, we come up with 4 different combinations of 2-point and 3-point shots that work in this inequality, and we write the combination as an ordered pair. So for example, 1, 2 stands for 1 2-point shot and 2 3-point shots. And this works because 2 times 1, so there's your 2-point shots, 1 2-point shot, plus, and then we have 2 3-point shots, so 2, or 3-point shots. So here's 3-point shots, and there were 2 of them. So this is 1 2-point shot, 2 3-point shots. We check, is that less than or equal to 12? And so if we do that, that's 2 plus 6, which is less than or equal to 12, and that works. Okay, so 1, 2 we can put on our graph, and we know that will work. So I'm going to go over 1 up 2. That coordinate would work in this situation. You could score 0 of each, 0 2 points and 0 3-point shots, and that would be less than or equal to 12. So that would be here. You could score 2 2-point shots, 1 3-point shot, and that would work. You could do 1 of each. You could do 3 2-point shots and 1 3-point shot. So all of these work, so I'm going to graph them. So we have 2, 1, 1, 1, 3, 1. And so this just illustrates that there can be more than one point that satisfies this inequality right here. More than one answer that can work. All right, so we come to the big piece of graph paper in class, and we do that. So it says, let's graph Michaela's inequality. Let's solve it, get y by itself, so it's in slope-intercept form, and then graph it on the previous page. So here was our equation. And let's solve for y. Let's get y by itself. So first I'll subtract 2x from each side. We got 3y is less than or equal to 12 minus 2x. We'll divide everything by 3. So we have y is less than or equal to 4 minus 2/3 x. Let's graph that. All right, so we start at 4, and the slope is negative 2/3. So start at 4. 1, 2, 3, 4. I should put x is the number of 2-point shots. And then y is the number of 3-point shots. Okay, so start at here, and we'll just go by 1. So the slope is 2/3. So go up to negative 2/3. So go down 2 over 3. We'll go down 2 over 3. And if we draw that line there, we can see that anything below that region had our dots in it. And so anything in that shaded area could be a possible combination of points that would work that would be less than or equal to 12. Okay, so what do we notice about the dots in the shaded region? Well, all the dots are in the shaded region. Number 6, why do you think we need to shade regions when graphing an inequality? And the reason is there can be more than one answer. Can be a lot of answers. A lot of answers that satisfy the inequality. There can be a lot of answers for the inequality. And then number 7 says, why do you think we use solid and dashed lines when graphing an inequality? What does a solid line represent, and what does a dashed line represent? So we're actually going to get into that. A solid line means the answer can be on the line. So if we go back to our graph right here, if you had any answer on the line, they could also fit the inequality. If you have a dashed line, which we'll look at, the answers can't be on the line. They can be above the line or below the line, but not on the line. So we're going to take a look today at how you graph linear inequalities. So I put the steps in a box here. You're going to get y by itself, unless it already is, because then we can identify the slope and the y-intercept. We're going to use those to plot a few points. We're going to determine is it a solid or dashed line, pick a point, test, and shade. So the first one, get y by itself, and it is. So then we're going to graph. The y-intercept is -6. That's the number by itself. So at -6, I'm going to put a dot. And the slope is 2. I'm going to go up 2 over 1, up 2 over 1 a few times. And it's going to be a dashed line because it's going to be all the answers greater than 2x minus 6. So if there's no equal sign, it's going to be a dashed line, which means our answer can't be on the line. It can be above or below. So there's my dashed line. And then we're going to pick a point, test, and shade. The easiest point to pick, and it can't be a point on the line, but the easiest point to pick is 0, 0 if it's not on the line. So here it's not on the line, we can pick it. And we're going to test it in this inequality. So remember we're testing as y greater than 2x minus 6. We're going to plug in 0, 0. So a 0 greater than 2 times 0 minus 6 is 0 bigger than -6, and that is true. If it's true, we shade the side of the line that that point was on. So the point was to the left of the line, so we're going to shade to the left of the line because since that point was true, it means all the points on this side are true. So any point to the left of the line would work in the inequality y is greater than 2x minus 6. All right, let's do the next one. First step, get y by itself. Okay, so we have to do a little algebra here. So we have 8, so I'm going to write it in black here. 8x minus 2y is greater than 10. Let's subtract 8x from each side first. We get -2y is greater than 10 minus 8x. We'll divide each side by -2. We get y is greater than -5 plus 4x because a negative divided by negative is positive. All right, let's graph it. Start at -5. Slope is positive 4. It means you go up 4 over 1, up 4 over 1. And again, it's a dashed line because there's not an equal sign, so we'll dash it. Again, we can test the point 0, 0 because it's not on the line. I'm going to test in the original equation. So I'm going to plug in 8 times 0 is 0, minus 2 times 0, which is 0. So you're checking, is 0 bigger than 10? And that's false. 0 is not bigger than 10. So what that means is we're going to shade the opposite side of the line that the point is not on. So it means everything to the right of the line would be true in this case because 0, 0 was false. All right, we'll try graphing a few more, and then this will be what is on your assignment. So this one, y is by itself, so we don't have to algebraically get y by itself. The y-intercept is -4. The slope is 2/3. It means you go up 2 over 3 and make a dot, up 2 over 3 and make a dot. There's an equal sign, so we're going to use a solid line. And we're going to pick a point, test, and shade. So I'm going to test 0, 0. So I'm going to plug in, is 0 less than or equal to, and if x is 0, that's 0, so -4. Is 0 smaller than -4, and that's false. So we're going to shade the opposite side of the line, which is below the line. Okay, next example. All right, so again, y is by itself. We'll start the y-intercept 5. The slope is -1 over 2. So again, if you see just the x, it's -1 over 2. So I'm going to go down 1 over 2 and make a dot, down 1 over 2 and make a dot. I'll do it a few times. Again, it's a dash line because there's no equal sign. Whoops, those aren't very good. Okay, we'll pick a point, test, and shade like 0, 0. So is 0 greater than 5 because the 0 over 2 would be 0. Is 0 bigger than 5? That's false. So we're going to shade above the line here. Okay, last two. Y is greater than or equal to -6, so I'm going to find -6. And the slope is 0 here. Whoops. If the slope is 0, it's flat, and there's an equal sign, so it's going to be a solid line. That's not great. There we go. All And then we want to shade where y is bigger than -6 and y is bigger than -6 above the line. The next one, x is less than 4, so we're going to find where x is 4. All right, so here's where x is 4. And remember, if it's an x line, it's vertical, and it's going to be dashed because there's no equal sign. And we want to shade where x is smaller than 4, so that would be to the left of the line. All right, so we've graphed inequalities. You're going to do the same thing here for your assignment. There's some that you have to solve for y and some that you do not. And you'll have some fractions in there as well, and a word problem.